In today's video, we are going to be covering negative and zero exponents. So in the last lesson, we learned about the laws of exponents, and sometimes we might get a negative exponent or a zero. And so let's dig into what happens in those situations. All right, so we have two fractions here. Let's look at the one on the left, 2 to the third divided by 2 to the third, right? So we know from our laws of exponents, the shortcut to simplify this fraction is to, when you divide exponents, you keep the base and subtract the exponents. So actually what I'm doing is keeping the base and subtracting the exponents, which actually means 2 to the 3 minus 3, which is 2 to the 0 power. So this is a scenario where we have a zero exponent. Now, what does that mean when I have a zero exponent? Well, let's take a look at this fraction expanded. So if I expanded this fraction, 2 to the third and 2 to the third, I get 2 times 2 times 2 over 2 times 2 times 2. Now, whenever you have a fraction, right, anything divided by itself is 1. So these would cancel, these would cancel, and these would cancel. Now, when you have things that cancel in a fraction, anything divided by itself equals 1, not 0, right? So if you take anything and divide it by itself, it's always going to equal 1. So that means anything to the 0 power is always going to equal 1. 2 to the 0 equals 1. 3 to the 0 equals 1. 4 to the 0 equals 1. 5 to the 0 equals 1. X to the 0 equals 1. Okay. Now let's take a look at this one over here in this case. So using the shortcut that we learned in the last lesson, right? Keep the base, 3, and subtract the exponents, 4 minus 6. Which is 3 to the 4 minus 6 is negative 2. So this is a scenario where we have a negative exponent. But now let's take a look at what that is when I expand it. So 3 to the 4th is 3 times 3 times 3 times 3. 3 to the 6th is 1, 2, 3, 4, 5, 6. Okay, let's cancel some things out. 1, 2, 3, 4. So I'm left with 2 3s on the bottom. And remember, when I cancel these out, doesn't cancel out to 0. It cancels out to, like you said before, 1. So it becomes a fraction where it's 1, since everything up here is canceled out, and there's 2 3s on the bottom. So it becomes 3 squared. So whenever you have a negative exponent, it goes to, did not want that. It goes to the bottom of a fraction. Okay, so 3 to the negative second is the same thing as 1 over 3 to the second. Okay, so a lot of people get confused and see a negative exponent means you're multiplying by a negative number. No, that means it goes to the bottom of the fraction, because actually this is written as a fraction. It doesn't look like a fraction because we're not used to writing 3 over 1, right? So what this does is it goes to the bottom of the fraction and becomes a positive. Okay. So let's take a look at some problems using the laws of exponents that we've learned and seeing whether we get a negative exponent or a zero exponent or a positive exponent. If it's a positive exponent, it stays the same. All right. So let's take a look at some. Let's take a look at these down here. Okay. So laws of exponents, these are all multiplying problems. So when you multiply, you keep the base, add the exponents. So you keep the 5 and you do -2 plus 5, which is 5 to the third. Now here, it's a positive exponent. We don't have to change anything in exponential form. This would be our answer. Okay. Let's take a look at here. Remember, anything without an exponent has a 1. So it's 3 to the 1 plus -1. 1 plus -1 is 0. Remember, anything to the 0 power is 1. The next one, keep the base, add the exponents. 4 to the -2 plus -2. -2 plus -2 is -4. Now remember, when we have a negative exponent, it goes to the bottom of a fraction. So you could write it as this. It depends on what the question is asking for. If it's asking for a negative exponent, you leave it like this. But if it's asking for a positive exponent, you have to flip it over the fraction. So it's 1 over 4 to the positive 4. Okay, so actually you could, depending on what is asked for, these answers would both be accepted, but most cases they're going to ask for a positive exponent. And so, if that's the case, you have to flip the negative exponent over the fraction bar. All right. So we have some multiplying problems. Let's look at some dividing problems. Okay. Remember, when we divide, we keep the base, subtract the exponents. So keep the base, and then 8 minus -1. Minus -1 is the same thing as adding 1. So it's 2 to the 9th power. And we keep that the same. It's a positive, so we just leave it 2 to the 9th. Okay, let's look at this one. Keep the base, subtract the exponents. So this, I'll write it down here. Give some space maybe for this one. 6 to the -2 minus -1. -2 minus -1 is -2 plus 1, which is 6 to the -1st power. Now again, if I want to write that as a positive exponent, you have to flip it. So 1 over 6 to the positive first, or it's just 1 over 6. You don't even need that first exponent. So that would be this completely simplified. And you could also do this with variables. Same thing here, okay? I want to give this exponent a 1. So keep the base, x -3, and subtract the exponents, -1, which is x to the -4th. Which another way I can write that is, you flip it, 1 over x to the +4. That would be my answer for that one. As a positive exponent. It says leave it as a negative exponent. It could be this. Okay. All right. So remember, when we divide exponents, we keep the base, subtract the exponents. All right. You guessed it. Next one is power to a power. Now, when we have power to a power, we keep the base and multiply. Multiply the exponents. So we have 6 to the -2 times -1, which is 6 to the +2, and we just leave it just like that. Y to the -6 times 4 is y to the negative 6 times positive 4, which is y to the negative 24th, which is, flip it, 1 over y to the positive 24th. And then the last one, 5 to the negative 3 times 0. What's negative 3 times 0? It is 0. Anything to the 0 power is? You got it. 1. You could also take a look at the beginning here. Anything. It doesn't matter what this is in parentheses. You could have a lot of different numbers inside of this entire thing. And if there's a 0 on the outside, it's always going to, again, equal 1. All right. So that's our lesson today with negative and 0 exponents. Remember the laws of exponents when you are multiplying terms with the same base. Okay, you add the exponents, you dividing exponents, you keep the base, subtract the exponents, and when you have a power to a power, you keep the base and multiply the exponents. Whenever you have a negative, you flip it. Okay, so negative exponent automatically tells me to flip it, and in order to make it a positive exponent. All right, so that's it for today's video. Thank you for watching, and remember, whether you're solving for X or Y, always give math a try.